already talked a bit about forces in terms of how they can change the energy of something, they can do work, they can change the movement of something. And today we're going to talk in a little more detail about Newton's laws and how they shape forces. So the basic definition we learned when we were talking about energy was that forces do work. That is, forces change the energy of something. If something's moving, they can change its direction or its speed. That is, they change its kinetic energy. If something's still and you make it move, you've given it kinetic energy. If you squash something that's elastic, you've given it elastic potential energy. If you lift something up in the air, that force causes it to change its gravitational potential energy. And this is related to one of Newton's laws, his first law in fact. And his first law says that a moving object, like a car or a ball or anything, a moving object will stay moving, and a stationary object, that is a still object, will stay still unless, and this is the important part, unless an unbalanced force acts on it. And I hope you can see from your own experience of the world that this is true. If a ball is sitting on the ground, it'll stay sitting on the ground until someone kicks it or picks it up or does something with it. And we would say at that point, when it's just sitting on the ground, we would say the ball has balanced forces acting on it. There's the ball and here's the ground. You know, and it could be a box and a table, it could be a person in the ground, it could be a car on a bridge. Whatever it is, there's an object and it's not moving. The object has a weight force, and I'm going to just draw that with an arrow, and I'm going to put mg next to it, because we know that something's weight force is its mass, and on Earth times the acceleration due to gravity. That's its weight force. So why doesn't the ball fall? Well, it's because it's being held up. We say, well, there's an equal and opposite response force holding it up, and I'm just going to call that F. I'm going to put a little R on it so we know it's a response force that's acting against it. Those two forces are equal and opposite. The ball's not moving. So far, so good. We know that a ball that's rolling along the ground will eventually stop. So maybe this first one we're like, oh, how does that happen? Well, if we think about it, so I'm going to put a little V on here for velocity. But as you'll see, you know that changes, it slows down. Why? You know, what's the thing going on here? And the thing that's going on here is there's a force acting back against it, a friction force. And I'm going to put an F, and I'm just going to put a little friction underneath it so you can be sure. So friction always acts to change movement. So in this case, the ball will slow down because there's an unbalanced force on it. So I'm going to put here balanced, ball stays still. Unbalanced, ball slows down. Okay, let's say we've got a car or a bike or a trolley or something, and we'll make it a car because that's nice and simple, and we want it to move with constant speed. We want it to keep moving. But we know that if we take our foot off the accelerator or we stop pedaling, we'll slow down. So there's obviously a force due to friction between the tyres and the road. So if we want to keep moving with constant speed, we need to keep pedaling or keep our foot on the accelerator. We need to provide a push force that is equal to the friction force. So we have a balanced situation here. So balanced, the weight force and the response force are equal and opposite, therefore the ball stays still. Unbalanced, there is a friction force acting, but no push force. The ball will slow down. Balanced, there is a friction force acting, but we are also applying a push force, therefore balanced, constant speed. So these are all situations you're really familiar with, even if you've never thought about them in terms of Newton's laws. So let's consider Newton's second law. Newton's second law is just a way of figuring out what a force does. So if we think about, for example, throwing a ball up in the air, we know that it will just go, or kicking a ball, we know that it will start moving. And we would say we've given it some acceleration. And so Newton's second law says that the force you apply will give the object some acceleration. How much acceleration it gives it depends on how heavy the object is and how big the force is. If we have a heavy object and we apply a small force, I hope you can see this movement won't change much. There won't be much acceleration. On the other hand, if we have a small object, like a little tiny tennis ball, and we apply a big force to it, like shooting it out of a cannon, I hope you can see it will accelerate a lot. Its speed will change a lot. So this A here is acceleration. And acceleration is just change in velocity. And we're going to define that for reasons that will become clear later. Change in speed or change in direction. And you'll be pleased to know that for year 11, you mostly are dealing with change in speed. So these two laws here are at the heart of what we do in NCEA Level 1. If there are balanced forces, the object will be still or moving at constant speed. If there are unbalanced forces, the object's movement will change. It will accelerate somehow. The amount of acceleration you get depends on the force and the mass. We will solve mathematical problems using this, but it's important for you to know acceleration is change in speed or direction, and it is caused by forces.